For years, the moon remained silent, while the footprints of the Apollo astronauts stood motionless in the lunar dust. Humanity turned its gaze toward Mars and the distant corners of the solar system. In 1976, the Soviet Union's Luna 24 mission brought back soil and rock samples from the moon, marking the final major achievement in this field and bringing an era to a close. For decades, the moon stayed in darkness, like the shadow of an outdated dream, until one morning, when new rockets began rising into the sky. First, SpaceX launches drew attention. Then NASA announced the Artemis program, saying, "This story is not over yet." But the real surprise came from China, advancing quietly and deeply behind the scenes. They had set their sights on the moon's mysterious far side, that dark face we can never see from Earth, where even radio signals struggle to reach. And that was exactly where the real curiosity began. But why now? What could have happened beneath the lunar dust after all these years that was calling humanity back? And was this race truly only about science, or could something hidden in the moon's depths shape our future? China's lunar adventure did not suddenly appear out of nowhere. Everything began in the 2000s with a long-term and quietly executed plan by the China National Space Administration. Even the mission's name carried a mythological reference: Chang'e, the moon goddess. In fact, from the very beginning, it was obvious that the goal was not romantic, but rather extremely serious. But this program was not driven solely by scientific curiosity. There was a far more strategic mind operating in the background. With these missions, China wanted to position itself not only as a spacefaring nation, but also as a global power. Because the moon is no longer just an ordinary rock hanging in the sky. The struggle for the resources of the future may already be taking shape right there. The first step came in 2007. Chang'e 1. China's first lunar orbiter created a detailed 3D map of the moon's surface. But here's the real bombshell. The spacecraft detected traces of helium-3 in the lunar soil, the regolith. So what is helium-3 useful for? If humanity can one day achieve nuclear fusion energy, and the scientific world moves closer to that goal every year, helium-3 could become an almost limitless and clean energy source. This element is extremely rare on Earth, but it is believed to exist abundantly on the moon, and that detail seriously captured China's attention. Then, in 2010, Chang'e 2 launched. This spacecraft was equipped with far more advanced cameras. The goal was clear: to obtain clearer images of the surface and determine future landing zones. The spacecraft flew at an altitude of only 15 kilometers, scanning for safe areas. It almost glided over the moon like a bird. And finally, in 2013, it was time for the grand spectacle. Chang'e 3 made a soft landing in the region called Mare Imbrium, in the moon's northwest. This was the first landing on the moon since 1976. Along with the lander, a rover was also sent to the surface. Its name was Yutu, meaning jade rabbit, a legendary rabbit believed in Chinese mythology to live on the moon. But Yutu was not merely a symbolic figure. It also carried the moon's first ultraviolet telescope. For the first time in history, a telescope was turned toward the sky from the lunar surface. This mission shattered the moon's decades-long silence. Suddenly, the entire world looked up at the sky, because China was no longer just watching from the sidelines. The biggest leap in China's lunar journey came in 2019. With the mission they called Chang'e 4, a country successfully achieved the first ever soft landing on the far side of the moon. Yes, that mysterious region we can never see from Earth. But this place is not interesting simply because it is unseen. The far side of the Moon lies within the South Pole Aitken Basin, one of the largest impact basins in the solar system, and the landing took place specifically inside the von Karman crater. This region is filled with traces from billions of years ago, almost like a time capsule opening into the Moon's past. But the far side has another unique characteristic: radio silence. Signals from Earth cannot reach there. This makes the region a perfect location for sensitive scientific experiments such as radio astronomy. But that same silence also creates a major problem: no communication. The Moon's mass directly blocks radio signals, meaning even if you land a spacecraft there, it cannot communicate with Earth. China solved this problem very cleverly. In 2018, they placed a communication satellite called Queqiao at the L2 point between the Earth and the Moon. The satellite was positioned in such a way that it could see both Earth and the Moon's far side. In other words, they built a bridge in the emptiness of space. And on January 3, 2019, Chang'e 4 made that landing. It went down in history as the first human-made vehicle to successfully land on the far side of the Moon. Just 12 hours later, the rover named Yutu-2 rolled onto the surface. Like the Jade Rabbit itself, it began exploring with silent but determined steps. The first images sent back by Yutu-2 were astonishing. This place looked nothing like the lava plains on the Moon's near side. The surface was filled with craters. In many areas, it appeared rough and chaotic. Scientists had long wondered why the Moon seemed to have two completely different faces. One side smooth and calm, the other scarred and heavily cratered. And this mission became a giant step toward answering those questions. The cameras and spectrometers aboard Yutu-2 began analyzing the region's geological structure. The composition of the soil, the types of rocks, the depth of impact traces. All of these offered valuable clues about how the Moon formed. So this mission was not merely a distant landscape, but also a window opening into the Moon's mysterious past. After the Chang'e 4 mission, things became even more interesting, because now the issue went far beyond simply achieving a successful landing. There were serious signals about the future. As the spacecraft moved across the far side of the Moon, the question slowly began to feel more realistic. Could this place one day host a colony? One of the most striking findings was something that had been discussed for a long time but never clearly confirmed. Helium-3 deposits. This element is anything but ordinary. If humanity can one day generate energy through nuclear fusion, helium-3 could become the key to it all. A clean, radiation-free source, capable of producing enormous amounts of energy. Just think about it. Only 80 grams of helium-3 could provide the same amount of energy as 10,000 tons of coal. Which means the Moon's helium-3 potential could theoretically supply humanity's energy needs for thousands of years. In 2020, another mission took place. Chang'e 5 returned samples from the Moon's near side, and among those samples, scientists discovered a completely new mineral never seen before. They named it Chang'e. This mineral, which contains helium-3, made China's ambitions regarding space resources even clearer. In fact, since Chang'e 1, all of these missions had been mapping the distribution of this valuable element across the lunar surface, because if a mining base is ever truly established there one day, humanity would need to know in advance where to extract what. But helium-3 is only one part of the story. In 2019, Yutu-2 discovered a strange gel-like structure inside a small crater, reflecting light like glass. At first, the images were not released, but once the spark hit the internet, there was no stopping it. Alien material? Hidden signs of life? Something buried beneath the moon? Speculation exploded everywhere. When the images were finally published, scientists explained that the structure was actually a glassy rock formed by a meteor impact. It contained minerals such as olivine and pyroxene. So technically not alien, but unquestionably extraordinary, because it revealed just how violent and high energy the impacts on the moon's far side once were, almost like a memory scar carved into the lunar surface. Another surprise from Chang'e 4 emerged in a completely different field: life, but not in the way we know it. As part of the mission, a miniature biosphere capsule containing cotton seeds, potatoes, yeast, and fruit fly eggs was sent to the lunar surface, and believe it or not, one of those cotton seeds sprouted. Yes, for the first time, a living organism began growing on the moon. Of course, the lunar night soon arrived. Temperatures dropped to -170 degrees Celsius, and the poor sprout instantly turned into frozen food. But don't focus too much on that part. What mattered was that tiny green sprout. Millions of kilometers away, it became the first small stirring of life on the moon. And in that moment, a massive door opened. It meant that if the right conditions could be created, farming on the moon was no longer just a fantasy. And for visionaries dreaming of permanent settlements there, this was a truly significant development. China's historic landing on the moon's far side was seen not only as a giant step for China, but for all humanity. Even NASA Administrator Jim Bridenstine at the time praised the achievement as a first for humanity. Just imagine it. For the first time, a spacecraft successfully performs a soft landing in that mysterious region hidden from Earth. Of course, because of political barriers, NASA and China's space agency, CNSA, cannot directly cooperate. Yet the scientific world still waited impatiently for the data coming from Chang'e 4. But why so much excitement? Because the moon's far side is completely isolated from Earth's radio signals, meaning a telescope built there could listen to deep space without interference. And beyond that, the surface contains craters that have remained almost untouched for billions of years, almost like a fossil record from the earliest years of the solar system. But once mystery enters the equation, things naturally become complicated. CNSA's ties to military structures and the secrecy surrounding parts of the mission gave conspiracy theorists endless material. Internet forums exploded with claims ranging from alien structures to secret lunar bases, especially after U-22 discovered that glowing gel-like substance in 2019 and then encountered a mysterious hut in 2021, which later turned out to be nothing more than a rabbit-shaped rock. But even that only fueled the rumors further. But when we look at China's real focus, it appears far more scientific and strategic in nature. A permanent base established on the far side would not only serve observation purposes, it could also provide extraordinary opportunities in terms of energy and resources. Take helium-3, for example. As I mentioned before, this material could become a clean and powerful source of nuclear energy. If extracting it from the moon ever becomes possible, the rules of the game could completely change. And it's not only about helium-3. Water is another massive issue. NASA's L-Cross mission and India's Chandrayaan-1 mission both showed the presence of water ice inside the moon's permanently shadowed craters. Samples collected by Chang'e 5 in 2020 also revealed water molecules in mid-latitude regions. In other words, the solar wind may slowly be embedding water into the lunar surface. One day, that water could provide drinking supplies for astronauts and also be used to produce rocket fuel. And that is exactly why China's lunar missions continue without slowing down. Chang'e 6 made history in 2024 by collecting samples from the moon's hidden far side. Next come Chang'e 7 and 8. These missions will search for water ice on the moon. They will even attempt to build infrastructure using 3D printers. Yes, I'm not joking. Printing buildings from lunar soil. We are now beginning to test what was once pure science fiction. But China is not alone on this path. NASA's Artemis program is also targeting the lunar South Pole through partnerships with private giants like SpaceX and Blue Origin. Both sides are searching for the same thing: sunlit ridges and ice-filled craters hidden in the shadows. Because these regions are considered the ideal places for establishing colonies in terms of both energy and water. And that is why the moon is no longer merely a subject of scientific curiosity. It has also become a field of strategic competition. Although the 1967 Outer Space Treaty states that no one can own the moon, the uncertainties surrounding resource sharing could open the door to serious diplomatic tensions in the future. Every hammer strike on the moon does more than just dig into the soil. It also pushes against the boundaries of international law. Yet this race is different from the rigid rivalry of the Cold War era. Europe provides technological and scientific support to both sides. Data is being shared, and some steps are being taken together. This time, small collaborations are emerging within the competition itself. And perhaps that is the only truly hopeful thing for humanity's future. With energy resources like helium-3, water ice deposits, and biological experiments, the moon has already begun preparing, whether most of us realize it or not, to become humanity's first extension into space. And perhaps the real question is this: are we ready to settle on the moon? Or has the moon already begun waiting for us? Just imagine it. One day, the first human to take their very first breath outside Earth will be born. And for that child, the moon will not be a mysterious glowing object hanging in the sky. It will be the place they call home, that distant, silent, and frozen world we see from Earth will feel like an ordinary neighborhood to them. And only then will humanity realize that this competition was never just about who did what. It was also about who did it first. And those left behind will often not be the ones who made the wrong move, but the ones who never made the first move at all.